Hello, hi. Today we are about to solve some questions on manometers. So quickly, you have been given a question. The height of the water, that's which has a density 1000 kilogram per meter cube. Column shown below is 80 centimeters. So the height of the water column shown below is 80 centimeters. What is the height of the oil column? If the density of the oil is 750 kilogram per meter cube. So this is our manometer, a U-tube shaped. So we've been given the height of the water to be 80 centimeters cube. So here we are looking at two different liquids. One which is oil and the other one which is water. But the height of the water has been given to be 80 centimeters. The height of the water has been given. So the question is we should find the height of the oil. So we first check the unit. The height or the density of the oil was 750 kilogram per meter cube. So we can try to convert all the terms with the centimeter cube. With the centimeters, like 80 centimeters. We will have to try to write it in terms of meters. So we make a conversion. The height of the water, which is 80 centimeters, converting to meters, you divide by 100. Listen, 1 centimeter is equivalent to 100 centimeters. So if you want 80 centimeters, definitely will be 80 divided by 100, which is 0.8 meters. Then the height of the water too, we don't know. That's what we've been asked to find in the question. They have been giving us to the density of the oil to be 750 kilogram per meter cube. So we will first consider a system to be in equilibrium. So the question was given for us to find the height. We don't know the height, so we assume the system to be in equilibrium. So we redraw the diagram again. So we know that the U-tube is open to air. Both the left-hand side and the right-hand side is open to air. So there is an atmospheric pressure which is acting downwards from our left-hand side. And also there is another atmospheric pressure which is also acting downwards. So we should note that for this system to be in the equilibrium, it means the pressure on the left-hand side, so LHS, the pressure on the left-hand side should be equal to the pressure on the right-hand side. That's the right-hand side, RHS. So this is our assumption for this system to be in equilibrium. And it makes sense because when the pressure of oil is greater than the pressure of water, it means the expansion of the oil affects the water and thereby it will cause the system to malfunction because the water will ooze out and we will not get a stable equilibrium. So know that the pressure of the left hand side is being acted upon. So we are first looking at the left hand side or the left tube. There are two pressure which is acting on the left hand side. The one is the atmospheric pressure, the one too is the pressure of the oil, because the pressure of the oil, because in fluids normally, because there is a height difference, and say gravity acting upon it, we normally write pressure in fluid as my density of the fluid times the gravity which is acting times the oil, times the height. So this oil has a certain height, h, and it has a certain density, and also it has a gravity which is acting on it. So when you multiply those factors, you are getting the pressure here. And also another pressure, which is the atmospheric pressure too, is acting downward. So you want to write the equation for the left hand side, this left tube. You are going to get the pressure of the atmosphere, that is atmospheric pressure, plus the pressure of the oil. So the whole this. After that, we also consider our right hand side of the tube. This one too, there is another pressure, atmospheric pressure, and also pressure of water, or the pressure due to water. So you know that water will have some density, and also there is a height difference. So the pressure on the right hand side will be the atmospheric pressure plus the pressure due to water. Okay, so we try to equate them because the left hand side should be equal to the right hand side. So equating the left hand side and the right hand side, we are getting the pressure of the atmosphere plus the pressure of the oil should be equal to the pressure of the atmosphere plus the pressure of the water. So the pressure of the atmosphere, or the atmospheric pressure, will cancel the atmospheric pressure. You know that it will cancel. So we are getting the pressure of the oil to be equal to the pressure of the water. Okay, so my pressure of oil 2 is equal to the density of the oil times the gravity times the height of the oil. Remember, it was of a particular height. Also, the density of the water to is equal to the pressure of the water to is equal to the density of the water times the gravity times the height of the water. So you know that the pressure of the oil was equal to the pressure of the water. So we can rewrite it as my rho g h of the oil should be equal to my rho g h of the water. So upon doing that, I know that my gravity is going to cancel the gravity. So here I know that my density has been given in the question, and also the density of the water too has been given. You know that the density of the liquid was given as 750. But remember, the height of the oil, we can donate it as H1, and the height of the water too, we can say let it be equal to H2. So I can rewrite the whole of this as my density times the height of H1 equals the density times the height H2. So upon making a substitution, we have to find the height of the oil, which is the H1. The density was given, that's the density of the oil, and the density of the water. So upon making the substitution, we make H1 the subject, which is the height of the oil. Then we have to divide through by 750 kilogram per meter cube. So upon dividing, we know that the unit will cancel, leaving only the meters. So my height H1 will be 1000 times 0.8 divided by 750, and we are getting 1.067 meters. So the height of the oil is 1.067 meters. Thank you.